Okay, so most everything we need to be able to solve quadratic equations, we've done. So we've covered like the major stuff. So first of all, we need to remind ourselves of what's standard form. So standard form is when we write equations this way: ax squared plus bx plus c. And this time we're going to do the following: equals 0. We always want to set our equations equal to 0. Seems kind of weird. But we're always going to set it equal to 0. And you're going to see why in a moment. But I just want to practice putting an equation in standard form. So here's an example. So let's say we have the following: negative 9x plus 2x squared equals 18 minus 3x. And on today's delta, you're going to have questions where they ask you to rewrite this equation in standard form. So all we got to do is push everything to the right. To the left, and make sure it's in order from quadratic term, then linear term, and then constant term. So let's bring over the 18 and the negative 3. Okay. So the 18, where would it go? Where? Mhm. It should actually, it should go at the end. But remember what happens when we bring it from one side of the equal sign to the other? A negative. Same thing here. We're going to bring over the 3x. But we're going to, if there's a like term that I can bring it with, I'm going to do that. So it's going to go here, right, with the minus 9x. But yes. So let's kind of clean that up. Looks a little messy right now. So next step over here, negative 9x and positive 3x becomes, then we didn't do anything with 2x squared, right? And then we brought over 18, negative 18 equals 0. We're almost there. Yeah. Just have these trade places. They don't have to switch signs because we're just moving within the same terms or the same side. So our final answer is 2x squared minus 6x minus 18 equals 0. Okay? So one of the things we'll have to do within the equation, if it's not in standard form, move things around so it's looks like this. Okay? Put it in standard form. This is our ultimate goal. So now that we have our equation in standard form and equal to 0, we have to use something called the zero product property. And it's really just some common sense math, if you think about it. Let me give you this example, and you tell me. Suppose we have a product that equals 0. Two numbers, and they equal 0. When you multiply them, they equal 0. So let's say A times B equals 0. Okay? Think about that. What's the logical conclusion, the therefore, that we can assume? One of the numbers has to be 0. If A times B equals 0, then either A equals 0 or B equals 0. Or both, right? Can they both equal 0? Yeah, 0 times 0 is 0. That's a property of 0, right? When you multiply with anything, you get 0. So this is called the zero product property. And this is how we're going to use it. So here's an example similar to what we're going to do. Suppose I give you something like this. X minus 3, this binomial, and then times x plus 7 equals 0. So think about that. X minus 3 multiplied times x plus 7 equals 0. So if we're multiplying these two binomials and they equal 0, don't one of these two or both of them have to equal 0? So what we can say is either x minus 3 is 0 or x plus 7 equals 0. Okay? So my conclusion is either x minus 3 equals 0 or x plus 7 equals 0. Well, we can solve those and figure out what x is, right? Look. I mean, it's almost too easy. Yeah, almost just flip the sign. Well, let me work backwards. Okay? I started off with these two binomials. Let me multiply them together. So I have x times x, that's x squared. 7x and minus 3x is 4x. Negative 3 times 7 is, yeah. So really what I have here is x squared plus 4x minus 21 equals 0. Then I would factor that, equals 0. Then I use a zero product property. And then I get my answer. So the answers for x in this equation are 3 or negative 7. Okay? And even if you have something a little harder, like 2x times 3x minus 1 times x plus 5 equals 0. Okay? So now I have three factors that equal 0. I have 2x that could equal 0. So I could say 2x equals 0. Or I could say 3x minus 1 equals 0. Or I could say x plus 5 equals 0. One of those, the zero product property says any one of those three factors could be 0. And now I just solve each one of these little mini equations. Okay, so let's see. 2 times something equals 0. What does x have to be in this case? 0, right? 2 times 0 is 0. Here I would add 1 to both sides and divide by 3. So x equals 1/3. And if you're wondering, how do you get that? Just solve it in your head. Add 1 to both sides. You get 3x equals 1. Then you divide by 3. You end up with x equals 1/3. What's my last possibility? Yeah, equals -5. Subtract 5 from both sides. So there's my 3 answers to this one. And this, if I multiply it all back together again, it's actually a cubic equation. What would I have? Well, I'd have some sort of cubic equation. Okay. So now the only thing really left to do is actually solve by factoring. We're going to do that extra step. Start from this and then go to this. Okay. So we're going to solve some equations by factoring. All right. So let me give you an equation, and then we'll solve it by factoring. Let's see here. X squared minus x equals 12. Go ahead and write that down. X squared minus x equals 12. Okay, so our first thing to do, move the 12. Set your equation equal to 0. So we're going to move the 12. Now it's -12. So x squared minus x minus 12 equals 0. Okay? Any questions so far? So now we got a quadratic and it equals 0. We would love to factor this. So remember factoring using that X game problem? We got to go back to that. Let's see if we can set one up. So what number do we want on top? -12. Yeah, the C value goes there. What number goes on the bottom? -1. So we want two numbers that when you multiply them, give you -12, but when you add them, give you -1. Perfect. So that means this left side factors to x take away 4 times x plus 3 equals 0. Okay? Any questions so far? All right. Well, zero product property from here. Either x minus 4 is 0 or x plus 3 is 0. And then from here, we just get our answers. And there's usually going to be 2. X is either 4 or x is 3, -3. And so here's our solutions. 4 and -3. And then so those are, sometimes we call those the zeros, and you'll see why when we start graphing again with these things. So those are the two answers to this equation. If I go back and replace x with either 4 or -3, they would work. You could test it out. What's 4 squared? And what's 16 take away 4? 12. What's -3 squared? And what's 9? Well, minus -3, which would be plus 3. 12. So there's our solutions. Okay, let's try one more at this level.
Does that work like no matter what?
No matter if they're factorable. So the catch is we were able to factor this. Next week we'll figure out how we can solve this if you can't factor. Okay. So number 2. Let's try the following. X squared plus 35 equals negative 14x minus 5. Okay, write that one down. So let's move this stuff over. So we're going to move the negative 14x over. It's going to switch signs. We're going to move 5 over. It's going to have to go with the 35, right? So let's see what we get. What's our new equation after we move everything over?
X squared plus 14x plus 40.
Plus 40. Thank you. Remember, 35 and the negative 5 became positive, so it gave us a 40 now. Okay, so we want a diamond problem here. And we have 40 and 14. What numbers would work there? 10 and 4. And they're both positive. So we end up with x plus 10 multiplied times x plus 4 equals 0. All right. So solve this one, guys. I'll take it from here. What's my solutions?
X plus 10 equals 0 or x plus 4.
Yeah, you could do that. X plus 10 is 0, or x plus 4 is 0.
X equals negative 10 or x equals negative 4.
There you go. There's the solutions. Negative 10 or negative 4. Okay. The only thing that could get a little tough is sometimes you might have to do factoring that's a little more involved. So let's practice one of those. We got 2 more examples and then we're done. Okay. So let's do 6x squared minus 8x equals 3x minus 4. Okay. So we want to solve this one. Let's bring over the 3x and the minus 4. 3x is going to go here. Minus 4 is going to go behind it. Let's see what we get. So 6x stays 6x. How about my next term? What's that going to become?
Negative 11.
And then how about my constant term? Plus 4. All right. So factoring this is going to be a little tougher. So it's going to be, remember when we have something that's greater than 1 here? Yeah, 6 times 4, 24. And negative 11. So basically, we want 2 negative numbers that when multiplied add up to negative 11. -8 and -3. Okay, so these are the numbers we want, but again, since we had a leading coefficient here, remember how we set up to factor this? You got to use a box method, guys. Yeah. The box rears its ugly head. 6x squared here, 4 here. We can put -8x here, -3x there. You got to do this. And in case you're wondering, why do we have to do all this? Quick reminder, we have a coefficient that's greater than 1. Okay, before we didn't have a coefficient other than 1. And we could get away with not doing that. Okay, so let's see here. What can I factor out of 6x squared and -3x? 3x. Okay, and then 3x, well, what can I factor out of -8x and 4? Negative, can we do a 4 or a -4? Okay. Let's do that. Okay, so -4 times some, well, let's do this. 3x times something is 6x. 2x. 3x times 2, okay. 3x times 3x, okay, well, 3x times what gives us -3x? And let's just check this out. -4 times -1 is 4. Okay, so it looks like we got our factors. 2x take away 1 times 3x minus 4 equals 0. Okay. What can we do now? Set this up. 2x take away 1 is 0. And then we got 3x minus 4 is 0. And so it's going to be a little tougher. You got to get rid of the constant first, plus 1. We end up with 2x is 1. Divide by 2. X is 1/2. So one of our answers is 1/2. Let's find the other answer. And 4. (3x equals 4). Get rid of this 3. X equals 4/3. So we get the answers 1/2 or 4/3. Okay. Last problem. Number 4. Okay. -3x cubed minus 3x squared plus 60x equals 0. Okay. So this one's cubic, by the way. So it's going to the third power. What do you notice here? Yes. We can factor out 3x. You notice that 3x does come out of each of these. So we're back to looking and factoring out a GCF if we can. In fact, I'd like to factor out a negative 3x. Get that negative out of the way. So let's divide out negative 3x from everything, because we can do that. Okay, so we're going to factor out negative 3x. And if I do that, let's see what we have left. So negative 3x times what gives me negative 3x cubed? X squared. And then double check, this times this would give me that. Okay. Plus x. Negative 3x times what would give me 60x squared? Double check, just if you multiply back, do I get the top again? If you do, you did it correctly. So now we have this and this. What should I do next? What do you think? Look, I'll give you a hint. Look at the, do that x thing. So now we're going to factor out using negative 20 and 1. What two numbers multiply to negative 20 add up to 1? Okay, that would work there. This is that, and then adds up to positive 1. So now this factors to the following: negative 3x times x plus 5 times x minus 4 equals 0. And again, we didn't have to do this whole box method because look, the leading coefficient is 1. So whenever you don't have some number other than 1 or just nothing there, you don't have to do the box method. When you see something other than that, you got to do the box method. Okay, so now we have three equations, don't we? Negative 3x is 0. X plus 5 is 0. X minus 4 is 0. And this is going to give us three answers. By the way, we're going to get three answers. What are they? Well, solve this. Negative 3x equals 0. So 0 is one answer. X plus 5 equals 0. X minus 4 equals 0. So we got these three answers: 0, negative 5, and 4. Okay. What was the highest exponent? Go back to the original equation. What was the highest exponent? 3. How many solutions? 3. Here, what was the highest exponent? How many solutions? 2. Yeah. That's called the fundamental theorem of algebra. All right. That is how to solve equations by factoring. So this is going to be on on Delta Math. It's on Delta.